All right, page 1. This is going to be terminating conductors. It's not going to be the most exciting stuff in the world. We're just going to talk about a bunch of different types of cables and how to terminate them. We're going to talk about, you should have, I know that y'all have talked about shielding and stuff like that in the past with Mr. Wally and the purpose of it. I think I've even talked about it with you, like we'll talk about that. Trade terms, attenuation is going to be important. You should know what coax cable is, drain wire, shielding. Those are all going to be good ones to note for this first section. My first highlight in 110, types of low voltage cables. First paragraph, second sentence through the end of the paragraph is highlighted. With the exception of communication cables that enter a structure and are terminated in an enclosure within 50 feet of the entrance, the NEC requires that low voltage cables used for installation must be listed and marked with an appropriate classification code. So if they enter the structure and are terminated within 50 feet, they don't have to be listed. And that's how a lot of people get away with that. Like the coax cable that's coming in your house for internet and stuff like that, it doesn't have to be labeled and listed because it should be terminated within 50 feet of coming inside your house. Page 2. Page 2, the top right or top left of page 2, that's that first started paragraph. I've got the last sentence highlighted. To be effective, the shield and drain wires must be grounded. So this is, the shield is like the aluminum foil wrapping, and then the drain wire is what goes along with that. Anybody, y'all talked about drain wires and shields before a little bit. I don't remember anything about them. You know the purpose of a shield? What's the purpose of a shield?
To keep all your energy inside the wire, not leaking out, or to just protect the line in general.
Not necessarily. So these are going to be communications like low voltage signals and stuff, low amperage, low voltage signals. So not necessarily keeping it in, but it's keeping other stuff out. So I can have a high voltage cable. Pretend we're looking at a cable like head on. I have a cable like that. All cables that have current flowing through them will emit electromagnetic interference. So that's like the field that's around this that gets weaker and weaker as it goes, but its strength is dependent on how much electricity is flowing through it, right? So if I have a big flipping 480 volt cable coming into a motor, and this is just one of them, and I put an instrumentation cable right here, it is going to induce voltage onto that cable, and it's going to mess with my communications. Does that make sense? So you put the shielding, which is just it's even thinner version of like aluminum foil. You put that around the wires, and then the drain wire usually goes with it, and you ground the drain wire, and that drops all your electromagnetic interference to ground. That makes sense? So this is all electromagnetic interference. So I think we'll talk about this as well, but you also, so these are 3 different types of cable. You have shielded, unshielded, and a multi-conductor cable with shields. So this one has a shield, which is aluminum foil, and a ground wire with your conductors on the inside. Unshielded just has your conductors. So this would be like a piece of Romex or something. And then you have your multi-conductor cable. So you can have however many pairs of conductors in here, and each one of them is individually shielded. And then you have an overall shield for the whole cable. And that's just, the more shielding you add, the more efficient you're going to be at blocking out that EMI. But the disadvantage is the more you add, the more expensive that cable is going to be. A cable like this is probably going to cost $3 to $4 a foot, whereas this thing is going to cost pennies a foot. So you don't want to just go with the best and everything out. You want to go with what you need, so you're not paying more than you should. top right. So I gave you all the top left, the last sentence, to be effective, the shielding drain wires must be grounded. Gave you all that one. Something to note on grounding drain wires, you ground a drain wire only on one side, not both sides. So whenever I would do this in a factory and stuff, say I had this wire right here and I was running it out to a piece of instrumentation, say as a pressure transducer, out in the field, I would hook that up out there, and then inside my motor control room or wherever your control room is, I would ground on that side, right? So I would not ground at the piece of equipment because sometimes it's hard to find a good ground out there and stuff might be moving around, but inside a control cabinet, in your control room or something like that, it's easier to find ground. And you only ground on one side to drop out all your EMI, so to prevent ground loops, because you can actually have electricity flowing through the ground that's going to mess up your communications if you're grounding too much. Top right of page 2, right above the mineral insulated cable, that last sentence up there is highlighted. Some cables are marked for use with direct buried cable or for use as aerial support by a steel wire messenger. So y'all seen like your power lines coming into your house? Like you have 2 insulated power lines and then one's bare. So that bare one is your neutral that's coming in, but that's your steel wire messenger. And when they say messenger, like they mean that's just going to hold the weight of the other wires. So that neutral is going to hold the weight of the phase conductors. And then you can have direct buried cable. So has anybody ever seen UF cable? It's like gray Romex.
With generators that run right there.
You run UF cable.
Yeah.
So that stuff's super nice because I think it's got to be 6 inches underground.
I think it's, down here it's 18.
18.
If it's by itself, I think it's 12.
Okay.
If we put it with gas, I think you gotta do 18 and 24.
Okay. There's like different code requirements for how deep that stuff has to go on the ground, but you don't have to run conduit. You don't have to run anything like that. You put this stuff. It sucks to splice. Like it takes a while to learn how to get the insulation off. Because everything, it's not loose inside of here. Everything's just.
It has like the loose. It's like string. It's packed all in there.
Yeah.
Everything you should sit there on everything just twisted and twisted.
Yeah.
It just one thing after another, constantly twisting.
111 unshielded twisted pair cable. So it might be good to know, like UTP, like a lot of times they'll call this UTP, unshielded twisted pair. In the top left of page 3, that second sentence is highlighted. They're currently available as category 3, transmission rates up to 60 megahertz, 4 up to 20 megahertz, category 5 and 5E up to 100 megahertz, 66A is 250 and 500 megahertz. You want to key in on that category 5. Category 5 or 5E Ethernet cable can handle 100 megahertz. So that's untwisted, shielded pair. So this is like Ethernet cable. Anybody ever terminated Ethernet cable? It's not super hard. Like you just have to untwist these and put them in. You got to put them in a certain order. Usually it's a type. I don't know if it's going to talk about it. In
We
this
were
one.
running Cat 5 at work.
Cat 5, yeah. So this is 5. That's this right here. So there's a certain color pattern that you have to follow on both sides to terminate these conductors. But there is, you can see in this one, there is no shielding. Regular Cat 5 cable. Industrial Cat 5 cable does have shielding. Third paragraph on page 3, first sentence is highlighted. Category 3 cable is the minimum grade acceptable for new installations. Category 3 cable is the minimum grade acceptable for new installations. This is Cat 3. I've never seen it. I've never seen anything other than Cat 5 cable, if I'm being honest. Category 5 is going to be your most common. I think they're coming. Cat 6 and 7 are out and stuff, but Cat 5 is so readily, like it's made so much that it's by far the cheapest. But Category 3 is probably cheaper than this, but it's, I don't ever see it. I've never seen it. 113, under carpet telecommunication cable, UTC. Flipping over to page 4. So that last sentence before 114 is highlighted on page 4 as an online test question. So make sure y'all mark this as an online test question. When installing under carpet cabling, high traffic areas, heavy furniture locations, and under carpet power cables must be avoided. La- 114, shielded twisted pair cables. So this is what you'll see quite a bit in factories and stuff. Let me give you my highlights and I'm going to talk about them. On page 5, the first sentence on page 5 is one highlight. For example, SUTP indicates that it has an overall braid shield, but no individual shield, pair shielding. So that's what this is right here. I don't have individual pair shielding, but I have an overall braid shielding. The next sentence is highlighted. UFTP indicates a cable with no overall shield, but with an individual pairs foil shielded. So that means it would not have this, but each one of these pairs would have a shield. And then the next sentence is highlighted. SFTP indicates a cable with both an overall braid shield with individual pairs foil shielded. So that'd be like this. Each one has a shield around it, and then the whole cable has a shield around it. Those are the highly missed questions on this test. You need to know the difference between SUTP, UFTP, and SFTP. Coaxial cable. Anybody ever terminated coaxial cable? I think I have at the house and stuff like that, but not a lot as far as instrumentation goes. I've run a bunch of it, but I never terminated it. Page 6. My highlight on page 6 is in that first bullet point. About a little less than halfway through, I've got a sentence highlighted. Coaxial cable provides a much higher bandwidth and better protection against electromagnetic interference than twisted pair cable. Coaxial cable provides a much higher bandwidth and a much better protection against EMI than twisted pair cable. That's why they still use coax for like AT&T and who's the other one around here? Cox. They still use coax cable to like run to your house and stuff. One, because it's pretty rugged cable. It can handle a lot of abuse, but it also has a larger bandwidth. And it also has higher protection against electromagnetic interference. So they run a lot of that coax cable. It's like the power lines that run all the way at the top of the power poles, right? And then the next layer down, that's all your like communication wires. So a lot of that is coax because it's not interfered with by the power wires. 120, low voltage connectors and terminals. 121, crimp connectors for screw terminals. This might seem dumb. Everybody's probably put on some of these crimp connectors before, but there is a correct way and definitely an incorrect way of putting these on. My highlights for 121, second paragraph, first sentence is highlighted. One disadvantage of indenter or crimp connectors is that special tools are required to make the joint. I like blue handled Kleins. Those blue handled Klein wire strippers are, I always have a pair of those in my bag, and those have, let me get. So like the bottom part of these, is where your like indentions are, like that's where you do all your connections. I like these just because it has about all the wire sizes I need. It has the crimp connections, and then even if you need to, you can cut down screws. It doesn't do a great job, but you can cut down little machine screws with these. Last paragraph on page 6, second sentence is highlighted. The insulation is color coded according to the connector's wire range to reduce the problem of wire to connector mismatch. So all these are color coded. I think yellow is like 12 to 14 gauge or 10 to 12. I can't remember which way it goes. But you have yellow, red, and blue are the 3 most common. Okay, you flip over to page 8. 22 to 16 gauge is red, 16 to 14 gauge is blue, and 12 to 10 gauge is yellow. It's not a bad thing to know. But another useful part of this is a lot of times the wire size is stamped right there on the tongue of these. So you never try to put like a 12 gauge wire. Like I've seen people like trim some of the strands of wire off so they can fit it inside of these barrel connectors. Don't do that. Get the right size barrel connector or crimp connector for the size wire that you have. I'm on page 7, 122 coaxial cable video and audio connectors. Second paragraph in 122, first sentence is highlighted. Coaxial cable connectors are employed primarily in Cat5 and cable modem broadband systems. So that's like your internet. Mobile broadband is like your internet. So that's why you usually have a coax cable plugged into your router or your modem at your house. I don't have anything on pages 8 and 9. Oh, I think there's a lot of pages in this chapter that I don't have. Like there's a lot of pictures in this chapter, so I don't have highlights in every page. You should on page 9. I don't think I have. Let me see if I can get to that in a hurry. Oh, I figured something else out that might be useful. So you know how this going to the certain page doesn't work well because of this? If you go in here and you type 1,000 or something you know is not going to be in there and hit this, it says, whoops, looks like that page doesn't exist, but this drop down has module 1 and then the page. So I can scroll. Where are we at? Module 6, page 9. 6, page 9. Only took me half a semester to figure that out, but it might make it a little bit quicker than flipping through these. So the thing to note with coax cables, like you can have this LRC or this is type F connector. So this is what you've had, like that you screw onto the back of your TV and stuff, like it has a screw connector. And then the more industrial version of that is the BNC connector. So this BNC crimp connector, this is just like a 90-degree twist, but both of these go on coax cable. So this is more like residential type stuff, and this is more industrial. I don't have highlights on that, but it is good to note that. Page 10 and 11. So talking about data communication connectors. Anybody ever seen these before? You mess with these or just
That's been a little bit, but not a lot.
like they're usually used for like telephone service stuff. What were you using them for? Remember?
My father brought a few home to play with.
Oh, okay. So
He was running PLC stuff.
gotcha.
He was bored.
So these are pretty much just terminal blocks, but they're called punch down blocks. But it makes for fast wiring because you don't have to strip the conductors. You can just throw them in here, and there's little. I don't think it shows it, but there's little like teeth in here that like bite into the insulation and they make a connection. So you can just lay the wire in there, push it in there, and then that cuts through the insulation and then makes a connection. So if you're doing like for this school, like I have an office phone, everybody has an office phone, all that stuff runs to one place. Wherever that closet is has these in it. But my highlight for this is on page 11, second sentence. Two popular punch down blocks are the 66 and 110 block. I didn't see these much in instrumentation, even with PLC stuff. I didn't see these types. That had to be for like very small stuff for running that, but you definitely see them with like where you have a lot of phones and stuff. 12 and 13, you just got different types of plugs and connectors. I think the same thing for 14 and 15. I think the same thing, 16, 17. I don't have highlights on these. You can go back and read through these different types of connectors. 18, 19, and 20. Just different pieces of hardware. I don't have anything highlighted. See if you take a couple minutes and do those two questions on page 21. Yeah. I don't remember who was in here when I said this, but just saying it again. I'm just going through, I'm gonna go through this chapter tonight. And then you can do the reviews and you don't have to do the reviews and stuff. I'm not giving you the reviews and stuff for homework, but Thursday is just gonna be a test day and then doing work. So if you want, I encourage you to do this stuff at home and then come in with everything done. I'm gonna take your answers, check everything. Just like I've done in the past, like I'll give you back your answers and stuff and have you find the ones that you missed. And once you have everything right, then you can take the test on Thursday. So Thursday is a test only day unless you didn't do your stuff at home, then you can do that on Thursday if you want to. But no class next Tuesday. one, shielded twisted pair cable is designated SFTP. What kind of shields is or are present? Find that. D. An outer braid shield and individual coil shield, so it has shields on both. 2. Coaxial cable and matching connectors are employed primarily in cable modem internet systems and
CATV.
Cat 5 cable, yeah. CAT. Cat 5. 1D, 2D. Section 2. Low voltage cable conductor termination procedures. You should know what amperage capacity means, grooming. We'll talk about mechanical advantage and service loops in this section. Termination of conductors or cables to solderless connectors. Conductor preparation, 211. Second paragraph, first sentence. For cutting cable and wire, a scissor action type of cutting tool is preferred. That is the second paragraph, first sentence. For cutting cable and wire, a scissor action type of cutting tool is preferred. Observe the following guidelines when stripping wire. So all the way at the bottom left of page, or bottom right of page 22. I've got that one bullet point on page 22 highlighted. Avoid nicking, cutting, or scraping the wire strands, or insulation surrounding the inner conductors of multiple conductor cable. This type of damage to the wire indicates that the wrong stripping group of the stripping tool was used. The tool was improperly set or damaged, the wrong type of stripping blade was used, or the tool was incorrectly used. Seems like simple stuff. Crimping tools, 212. The last sentence on page 23 is an online test question. Using a crimping die that is too large or under crimping gives poor electrical performance. A die that is too small or over crimping gives a very weak mechanical connection because it literally destroys the crimp barrel and weakens the conductors that it's joining. So you have to have the right size, like you can see it, crimp termination, like you can see where they crimp with this one. If it's too big, it's gonna have a poor electrical performance. If it's too small, it's gonna cut through that connector and it's gonna provide poor like you're gonna be able to rip that wire out of the connector. So you want to be like the mechanical advantage and the electrical advantage are not at the same place. So you want to do that, crimp somewhere in between, and no, you can't. This is kind of one of those things, like the more you do it, the more you're just going to get used to doing it correctly. So the mechanical advantage actually happens before the electrical advantage, but you want to find somewhere right in between so that it has the highest mechanical and highest electrical advantage combined together. Does that make sense? So I don't have any highlights at all on pages 24 and 25, but you can see on page 25 the different types of crimp configurations that there are. So they have a ton of different types of specialty tools to make these different crimps. Mostly I'm just doing crimps with my blue handle Kleins, but they make a lot of special tools with different dies that you can put in to make different types of crimps. Crimping procedure 213. So page 26. Page 26, I have step 4 highlighted. Train the wire strands if strands are fanned Grooming the conductor provides a proper fit in the crimp barrel. So if I go back to grooming, it's the act of separating the braid in a coaxial conductor. So that's just making your wires and stuff neat before putting them inside the crimp barrel. There's nothing special about that. Termination inspection 214. Pretty much what I do is a tug test. After I do it, I tug on it. If it falls off, it's no good. I look at it visually and see that stuff, if it looks right. Like if you look at page 27, you can see like if the wire hangs out too much, that's not right. If it's not in enough, you're not going to have when you crimp this, it's going to shove the wire out of the barrel connector, so it's not going to have a good mechanical connection. All I do is I stick enough copper through here to where I can barely see the copper, and that's where I make my crimp. You also never want copper more than a 1/16 of an inch outside of here. Usually they give you a little bit of playroom right here, but don't strip 2 inches of copper off or insulation off of this thing, throw it in there and crimp it. Like that's not gonna work. But 214 termination inspection, top left of page 27. That first paragraph on page 27, second sentence is highlighted. A poor connection result if a crimp is placed over either the belt mouth of the inspection hole of the terminal as shown in figure 26. Placed over either the belt mouth or the inspection hole. So you don't want it. You don't want your crimp here. You don't want your crimp here. You want it right in the middle. Page 28. Terminal block connections. Anybody ever seen terminal blocks like this? Spring-loaded terminal block? Maybe not. So these are very quick. You can put a lot of wires in these pretty quick. If I zoom in here, you can kind of see your wire goes in this bottom side hole right here. So all these slots are all different termination points. So each oval hole is where your wire will go in, and then you take what I call it a tweaker screwdriver, like a little bitty flathead screwdriver that you should carry around with you if you're doing this stuff. You stick it in here, and you can depress the spring that releases tension on the wire down here. So you stick your screwdriver in here, release tension, put your wire in, release your screwdriver, and then that holds. You always do a tug test on those and make sure that it's holding well. My highlights, 215, page 28, second paragraph, last sentence. After the wire is inserted, the screwdriver is removed and the wire is clamped in place by the spring contact. After the wire is inserted, the screwdriver is removed and the wire is clamped in place by the spring contact. Last paragraph on page 28, first sentence is highlighted. When installing wires on a common screw type terminal block, only 2 terminals are permitted at any one terminal point. You can't shove 5 wires in a termination point. Can't shove 5 wires in a termination point. I'm sure everybody will see it done. Don't do it. So like you can have pin connectors. It's always nice to have pin connectors and stuff like that, but I wouldn't get used to it because you don't see them that often. But typical screw block termination, I can only throw 2 conductors in each terminal spot. Termination of coaxial cable 220, page 29. Second paragraph, second sentence are highlighted. They are usually terminated with F connectors, although B and C connectors are used in some instrumentation settings. So that's like what I talked about. This is the B and C connector. Anybody seen these? You see where they're useful because you just kind of shove it in there and turn it 90 degrees and it's in there. Everybody's probably fought with a coax cable trying to get it to start threading on the back of your TV. Sometimes it's a pain in the butt. these just make it a lot easier. So this is B and C, the regular coax like this is type F. They go through the steps on how to terminate these. So with page 30 and 31 is all terminating with the B and C connector. I do not have any highlights in that. The picture on page 30 might be useful. Like the left side are all correct terminations, the right side are incorrect. Might be worth reading through that. Or just looking through that. I don't have any, like I said, I don't have any highlights in pages 30 and 31. They just talk about crimping that. I do have a highlight for crimping B and C connectors. Page 32. Page 32, I have step 18 highlighted. Step 18, after both ends of the cable are terminated, use a multimeter in resistance or continuity test mode to check for continuity of the center conductor from the pin and the connector body to the connector body. Then check for shorts between the center connector pin and the connector body. So if I'm looking at one of these cables, this cable has two terminations, right? It has this center point that goes in here, so that's one conductor, and then the other conductor is the outside of it. So whenever you're done terminating these, you take a multimeter, you take both ends of your wires, and you put one end on the outside right here, and the other end in the outside of the cable right there, and make sure there's continuity, make sure there's a connection. And then I put it on the center pin on this side, center pin on the other side, and make sure there's a connection. And then I put it on the center pin and the outer side on this side and make sure there's no connection. Does that make sense? So that's step 18 on page 32 is highlighted. Terminating a type F connector 222. I have step 7 highlighted on page 32. For a crimped connector, make sure the crimping tool has the correct die for the F-type connector being crimped. Place the crimp tool over the connector ferrule and squeeze the tool until the die is completely closed. Repeat for the second crimp if necessary. Always put a second crimp in there. So you can see on page 33, you have the first crimp and the second crimp. Always put 2 crimps in there if at all possible. Cable conductor routing and inspection considerations. The first bullet point on page 33 is highlighted. The procedures for cable conductor routing and inspection include the following considerations. First bullet point is wire bends. For UTP and STP cable routing, use a minimum bending radius of 4 times the outside diameter of the wire or cable, unless otherwise specified by the cable manufacturer. Maintaining the correct bend radius is especially critical for very high bandwidth applications, such as those handled by Cat 5, 5E, and 6 cables. So this is what they're saying. You don't want to come out here and immediately go to the termination. You want a service loop that is inside of these. This one has an excessive service loop. This is optimal. This is the minimum acceptable. And that's not enough. Page 34. First bullet point. I've got two separate highlights in that first bullet point on page 34. First sentence is 1, protection of wires or cable provides sufficient clearance between the conductors and heat radiating components to prevent deterioration of the insulation due to heat. You don't want these wires next to a furnace or something like that. The heat will warm up the insulation and break it down. And it's going to turn everything crispy or make the insulation not hold that well. The last sentence in that bullet point is also highlighted. Use grommets, chase nipples, or some other similar type of guard to protect insulation as wire passes through a metal partition. So if you're going through a metal box, make sure you have some type of grommet or something like that to where your stuff's not gonna rip apart on the metal. This second bullet point, the whole thing is highlighted and it's highlighted and it's also an online test question. Service loops allow sufficient slack at the termination of each wire to permit one repair, such as cutting off a terminal and re-terminating. So if I'm looking at this, this has a proper service loop. So if something happens to this, I can cut this back and I can still put another termination on this, right? Do not put 6 feet of wire inside of a box and it's for somebody in case you need it. I see too many people do that. They do a big long pole and stuff like that, and it's not easy. And they'll wrap up 6 feet of wire and shove it inside of a box. That causes more issues than not. Like you're never gonna have to trim back however many feet of wire. Like if you wanna leave a little bit more than this, you can leave an actual loop and go in so that you have a few chances to terminate if you need to. But I see too many people leaving a ton of wire inside of J boxes, and it causes more issues than it's worth. Electromagnetic interference. So that's what we talked about. 240 EMI. Third paragraph of 240 is highlighted. Third paragraph, first sentence is highlighted. Adequately separating low voltage circuits and any potential EMI sources addresses the problem in most installations. Separate your communication cables from your power cables. That will eliminate a ton of problems. Page 36, 241, electromagnetic interference guidelines. First sentence on page 36, if additional protection against EMI is required, refer to the following guidelines. I have the second bullet point highlighted. Multiple conductor cables should consist of twisted conductors. So you see all the, well, I already had, not in this one, but those twisted conductors that were on the board, twisting conductors actually helps eliminate electromagnetic interference. So that's why they have twisted conductors, because it helps eliminate EMI. Still going along with this, page 38, first bullet point on page 38, where unshielded cables of different signal conditions must cross, they should do so at right angles, not gradually over long distances. So if I have two wires running alongside each other, and say my black wire is my power wire, and I have EMI, I do not want to run them parallel. I want to run straight across this so that there's only one point where that electromagnetic interference can interfere with my communication cable. That makes sense? So that's what it's saying, run it at a right angle, 90 degrees, rather than parallel. Terminating typical shielded cable. Second paragraph, the whole second paragraph of 242 is highlighted. If the shield or drain wire could possibly come in contact with other shields or drain wires, terminal block points, equipment or equipment cabinets, they should be insulated with insulated tubing or heat shrink tubing to prevent short circuits and circulating currents. A cable that has individually shielded conductors with separate drain wires must have each drain wire and shield tape insulated to eliminate possible circulating currents. So if you had that big conductor from the beginning, you have to individually ground all of those drain wires. All right, got some more pictures on page 40 and 41. Then you got 4 questions on page 42. if y'all can knock those out right quick. Go get those. Number one, wires installed in a spring-loaded terminal blocks are held in place by spring contact, A. Two, coaxial cables are terminated with B and C connectors or
See, F connectors.
type F connectors, which is C. Three, a service loop should contain sufficient extra wire to allow. Colby, what'd you get?
3.
Three repairs.
One repair.
One repair. Service loop should contain sufficient extra wire to allow for one repair. Four, primary solution for EMI interference in low voltage circuits is adequate physical separation. Separating your communication and your power wires. Section 3. Testing and troubleshooting. This chapter has a lot of online test questions, a lot of them. So make sure when y'all are studying for this test that you are hitting these online test questions. Those will mess you up. Test equipment. I have telephone test set highlighted. The whole thing is highlighted. It is going to be a module review, a practice test, and an online test question out of this one bullet point. Excuse me. Telephone test set. The device in figure 53A is a handheld tester that connects to a phone line with alligator clip leads. It can function as a station receiver, telephone, test the operation of the subscriber service as a subscriber service to test the premises wiring, or a continuity tester to ring out conductors. Anybody know what ring out conductors means? So the definition is a cable or connector continuity test procedure in which a pair of telephone handsets powered by batteries are used to check continuity or to identify a conductor. That doesn't, to me, that doesn't really make sense. So what ringing out a conductor means is if I have, say I have a cable with 10 leads on, or 10 wires in it, right? And that cable runs out from a control room out into the plant somewhere, but I don't know, the wires aren't color coded, or it's so old you can't tell what color they are. They're numbered. A lot of times the numbers fade off, or as soon as you touch them, they wipe off. So ringing out a conductor is having you on one side. You can do it by yourself, it's a pain in the ass, but it's easier with two people. So on one side, somebody's taking those 10 conductors, and they strip 2 of them back and they connect 2 of them together, right? So on the other end, somebody takes a multimeter in resistance mode, and they go through all the wires and they see which 2 are connected, right? And then you have those 2 wires are identified. You can also go to ground if you have a good ground, and you can test each one to ground and see which one it is. But it's pretty much, it's mapping out which wire's what on both sides. That makes sense? So you can do it by yourself if you wanted to, like, go to one room, hook 2 wires together, go back out, see which ones they are, go back and forth, back and forth. You can do it by yourself, but it's a lot easier with a shift partner or something. But that is what ringing out a conductor means. The next bullet point, last 2 sentences is an online test question. So the tone generator and cable toner, last 2 sentences. This equipment can be used to verify circuit continuity through several floors and rooms of building. It can also be used to trace unlabeled wires from one point to another. If I showed y'all the cable tone tracer, I'll just. Am I showing y'all this? No. So, you ever seen one of these? Super useful. Actually just came out with a Klein one that's gonna change the markings. But if you have a wire and you don't know where it goes, or at least you know where it goes, but you don't know which wire it is, you can actually take this, it has to be off, the system has to be off, wire has to be turned off. So I clip this to the 2 wires. Say I have a twisted pair, I clip this. These are just little alligator clips. Clip that to each wire, and then I can take my wand wherever I'm going. I can search for it. When I get close, it sees it. This can go through walls and stuff like that. Like they're super convenient. So Klein came out with one that's about 200. This is about 100, 150 bucks. Klein came out with one that's about 250 bucks that will do live wires, which is fantastic. Like, you don't have to shut stuff down to find wires. I recommend one of those. You'll see. So there's that. So this can be called a toner. I've heard it called a tick tracer. I've heard it called a fox and a hound. Multiple different names for these. Tone generator, and cable toner are what they're calling it in this book. So this is the new one, $240. You can, come on. Like you can use one of these and it'll find live wires, which would be super useful. But that would be something I don't know, like I might buy one. Actually, I might just have the school buy one of these. In case I ever needed it, but that's not a bad price for what this is. What I would recommend y'all getting. Y'all seen these? Y'all use these?
This is Steve using.
It's fantastic. You plug this into a socket in your house. You don't know what your breakers are, and then you trace this down your breakers, and it lights up on the breaker that it's connected to while it's live. Like super useful. You can buy, like I would buy this little one down here because you can I can't get on there, but you can see the one you can plug into a light socket, so you can see where your lights are fed from, stuff like that. And then you can see, like, that's $55. This is, I own one of these, worth every penny. Like, I recommend everybody get one of those. All right, back on topic. Yeah, gave you all that one. So it can look something like this. So the toners, like this is kind of like the one. This is like what my personal one looks like. This is why they're called the Fox and the Hound, because you can have, like, that's a name brand of them, all different types. This is Ideal, Fox and the Hound. This is Fluke. Mine is Greenlee. You have all different brands of those. Cable tester, next bullet point is highlighted. Cable, first sentence, the equipment shown in figure 53C is used to test UTP and STP cables for continuity, shorts, opens, crosswire conditions. So whenever you make up Ethernet cables, you plug both ends into this, and it sends a signal through each individual wire, and it makes sure each wire is good. That's all it does. For an online test question, that beginning of that next sentence is highlighted. A cable tester is also known as a wire map tester. Online test question. Also known as a wire map tester. So that's the immediate next, that's the second sentence of cable tester. Page 44. They're just going through all the different types of devices. 44, third bullet point on page 44, you have the certification field tester. You need to know, like, it's just a very short part. In the second sentence, you need to know that near end crosstalk is called next loss. So it says near end crosstalk, and then right after it says next, that's loss. Test parameters 320. First sentence on page 45 is highlighted. Measuring attenuation is measuring the signal strength loss over the length of a cable. So attenuation is the signal strength loss over a length of cable. I can't put a 5 milliamp signal on one end of the cable, run it 6,000 feet that way, and expect to see 5,000 or 5 milliamps or whatever on the other side. That will dissipate over that length of cable, right? So you'll have to put in like amplifiers or something like that along the way. But that's what attenuation is. It's the loss of signal. over a length of cable. Troubleshooting, 330, page 46. First sentence on page 46 is highlighted. Opens, short circuits, or cross conductors are easy to detect using a cable tester. The next paragraph on the right-hand side, I've got the first sentence and the last sentence are one highlight. A time domain reflectometer, TDR, can also be used to detect and locate opens, shorts, and grounds in a cable. And then last sentence, many TDRs can provide the distance to a fault within a few feet. I need to buy one, like I've never used one of these. But if you have problems inside your cables and stuff like that, you can use one. Supposedly you can use one of these and it'll find it to within a few feet. So if you had 6,000 feet of cable and you didn't want to replace the whole thing, you could go do some type of termination in there and save all that. This TDR will help you find the exact location of where the fault is. Page 48. The paragraph that's right above 331. The last, is that all one sentence? The last sentence is highlighted. It's more than half the paragraph. If the required equipment is not immediately available, the DC loop resistance of conductors or coax cable can be measured using a multimeter to set up, measure resistance, and cable length or distance to a short can be approximated as described in the following section. All they're saying is you can measure DC resistance, and based on that resistance, all cables have a spec sheet that comes with them, or you can look up on Google and something like that, and they say how what the resistance per foot is. So you can measure DC resistance, and based on that resistance, you can divide by the amount of resistance per foot, and that's how you can find it. So instead of using a time domain reflectometer or a TDR, you can use this loop resistance method to find it. And they go through the steps on how to do that for a pair of conductors or for coaxial cable. It's not something I've ever done, but it is an option. I don't have any highlights in 331 or 2. 340, cable failures, mechanical failures. Top right of page 49, that last paragraph before 342, first sentence is highlighted. Mechanical failures are also caused by physical damage to the cable, such as that created by sharp edges. You can have mechanical failures. Environmental failures, 342, second paragraph, or last sentence before 343. Cables damaged by environmental factors often show discoloration or fading of sheath or wire insulation colors. Anybody ever seen Romex that's been outside for a while? You should never run Romex outside, like the yellow Romex that's inside your house. That's not outside wiring. If you leave it outside for a long time, it'll fade in the sunlight and it's going to get real brittle and start cracking and stuff. So you can have environmental failures. Thermal failures, 343. A whole second paragraph is highlighted. Some cables do not perform well in very cold environments. Typically, their insulation and sheathing can become brittle under these conditions and fail in multiple places if flexed. The next paragraph, I've got the second and third and fourth sentence highlighted. So starting at the bottom right of page 49, cables used in air spaces, such as those above suspended ceilings and in air plenums, must be rated for safe behavior during a fire. Many ordinary cables will burn or melt and release toxic fumes that can spread through the airspace into other areas. For this reason, special plenum rated cables are available for these installations. Electrical failures. The second to last sentence on page 50 is highlighted. Instrumentation cables can also be damaged by high voltage spikes or large induced voltages caused by lightning. Lightning can cause a lot of issues. Questions? Not the most exciting chapter, but it is important, especially if you've never done shielded cable stuff before. So, not for homework, but you can do it for homework if you want to get done real quick on Thursday. Section 3 review, module review, and practice test. Who doesn't have a practice test? So, the goal on Thursday is to take your test. If you want to come in and work on this, you can. But if you do this stuff at home, come in with the right answers and I check it off, you can take your test and be done till next Thursday. So that's all I have for tonight. Colby, you ready for any tests?
I was out all week last week with COVID. I can bring you a doctor's note if you want.
Do that. As much as you missed, yeah, I'll need to see that. Can you come in early on Tuesday?
Tuesday, you see we're gonna be here Tuesday, or Thursday.
This Thursday.
Yeah, I'll be here Thursday, early.
What time?
I can usually get off around, or at least usually get off like 3:30, 4 o'clock, 19, like 30 minutes to get here. Probably get here.
So I start class, my next class will start at 4:30. So if, like, I'm gonna study for the, I don't know, how many, you have, what is it?
Yeah, like 3 or 4.
Modules, no, not 3 or 4. We just did what, module 6?
6.
6, so you have 6 tests to do.
I thought I made up 2.
You took them, but you didn't pass them.
That's one of them, I know for sure. I thought
I don't think so. You know your card number off the top of your head?
I think I have it down right here.
I can find it.
Thursday.
See you on Thursday.
First word I came in here. Like I took 2, passed 1, and might not have passed 1.
I mean, I'll look and see, but I don't. You passed one. Good night. I got your, I don't know if you want to write this down. 267 59213.
See Thursday.
See you on Thursday. I mean, it'll be. You're taking 4 right now, aren't you?
Yeah.
Relays and timers, you got a 50. Detectors, secondary elements, transition transmitters, you got a 44. Electrical circuitry, you got a 56. That's the only 3 that you've taken. Are you sure you're not thinking about a core? Because you failed a couple core you failed 2 core tests that you did pass. Because you had future and construction.
That might have been what I was thinking about.
And your hand tools you failed and then retook and passed. So
That's
you don't
what I
have,
was thinking about.
you don't have any tests for me.
Alright, I know I keep saying it, I know I'm putting you in a bind, but
Well, the only thing I'm worried about is
I'm putting
like,
myself in a bind by getting my bind. but-
there's like, because I take the first test grade. So right now, you've taken 3 tests, and you have a 44, 56, and a 50.
So I need to,
So the other tests you take have to bring that up to above a 70. In order to just pass the class, not only just to get the certification, but to pass the class. I just don't want to get to, if you get to the point where you need to drop, like there's a drop class day, you don't, You don't need to fail the class, you need to drop the class if we get to that point.
Yeah, I'm not gonna, I don't know, I can't get to that point, I know,
Then you gotta
get down.
be ready for these tests when you come in on Thursday.
Yes, sir. And I'm gonna make sure I have everything, if not, I'm gonna shoot you an email, I'm pretty sure I got all my tests though, and everything.
Oh, okay, yeah, if you don't have something, shoot me an email and I can resend you the test.
Alright, thank you. Yeah, we go.
You too.